Last class we did it up to this much we have done it. The last class, if you remember it, here oxidation takes place because you can see oxidation reaction is taking place. So electrons is accumulating here, and as a result the electronic current flows from zinc to copper, and as you can see this is a positive electrode, so the conventional current flows from copper to zinc, we can say that. Clear? So here the reduction is taking place. I can see here gain of electrons is reduction and loss of electrons is oxidation, we can say that. Now what you find is that I said you that without the salt bridge this reaction is not possible because the cell is not complete. The cell reaction is not complete. So what is the function of the salt bridge? Write it down. First function is that cell bridge, it connects the two half cells. I said you last class, this is your oxidation half cell, this is a reduction half cells. It connects the two half cells and thus it completes the circuit. We can say that. It connects the two half cells and it completes the circuit. Point number one. Point number two, the function of the salt bridge is it maintains the electrical neutrality of the cell. It maintains the electrical neutrality of the cell. That means the cell is remaining electrically neutral in nature. Now this you have to understand it. That how the cell remains electrically neutral in nature. Understand. See, I think you have written it, the two functions, what I said you. So what you find is here that sulfate ions get accumulated. Alright, because zinc sulfate, what you can say, your zinc ions get deposited. Now zinc ions, it is coming from where? It is coming from zinc electrode, the zinc ions. So zinc ions, what you find is that here it reacts with the sulfate ions because zinc sulfate will dissociate to give you nothing but Zn2 plus SO4 2 minus. Alright, so this zinc will react with sulfate to form what you can say zinc sulfate. So ultimately what you will find is out that zinc ions get accumulated here. So this becomes what you can say slightly positive. This particular cell becomes slightly positive. Clear? Done now. Next, here what it happens. Here the sulfate ions accumulate. Sulfate ions get accumulated here. How? Because copper sulfate dissociates to give you Cu2 plus SO4 2 minus. So Cu2 plus gains 2 electrons to form copper, which gets precipitated here at the bottom, you can see that as a reddish brown PPT. But the sulfate ions gets accumulated. So this cell becomes slightly electronegative and this cell becomes slightly electropositive. So it becomes charged or not? Yes. So now the function of the salt bridge, you listen what I said. Salt bridge maintains the electrical neutrality of the cell. So when this becomes slightly electropositive, Cl minus ions comes from here because in the salt bridge what is there? KCl I have taken, either KCl or ammonium chloride or potassium nitrate. I said you, it should be an inert electrolyte which should not react with these two electrolyte. I said you the last class. So what will happen here? As zinc ions get accumulated, listen carefully, zinc ions get accumulated as you can see it here. Alright, so it reacts with the Cl minus ions. Cl minus ions come from here to give what you can say zinc chloride. So it becomes what? Electrically neutral. It becomes electrically neutral. Now how Cl minus ions will come? Does Cl minus ions know that I have to react with zinc? No. How it will come? See here. When the two electrons from zinc, when zinc loses 2 electrons, this 2 electron goes from to zinc and it reaches here copper. So copper reacts with this 2 electron to form copper metal atom. Then what will happen? Now what will happen is that the sulfate ions, SO4 2 minus, the sulfate is not going to move, the matter is not going to move, the ions is going to move. Alright, now how the ions is going to move? Potassium ion is going to pull the sulfate ions towards itself. Listen carefully. Potassium ion is going to pull the sulfate ions towards itself. As a result, the charges enters through this. Alright, the charges enters through this and hence it gets electrically neutralized. The charges when it enters. Now the charge has to also pass through this. So how the charge will pass through this? Zinc will pull that particular charge towards itself. Which charge? The negative charge is going to pull towards itself. That is Cl minus ions ultimately comes towards this side and it becomes what? Zinc chloride. And here what it happens? The sulfate ions is being pulled by the potassium ion to form potassium sulfate. And here the zinc ions is being pulled by Cl minus ions to form zinc chloride. So who is pulling here? That is your potassium ion is pulling the sulfate ions. As a result you can see the charge enters. And here who is pulling? The zinc ions is pulling the chloride ions. So the charge leaves from here. The charges enter and it leaves and hence the circuit gets completed. So the circuit not only gets completed, Alright, not only the salt bridge helps to what you can say complete the circuit and helps to connect the two half cells, but at the same time it maintains the electrical neutrality. Understood how it maintains electrical neutrality? Zinc ions pull the chloride ions to form zinc chloride, neutralized. Here the potassium ion is being pulled by sulfate ions, and hence it gets neutralized. In this way, this is the function of the salt bridge, and thus the reaction goes on. Got it? So this is the what you can say function of the salt bridge, and this is your entire working of a galvanic cell. We can say that. Now we will study how to represent the cell. Now see, here you can change the electrolyte and the electrode, and you can use different what you can say cell you can make it. Now this is a galvanic cell. You can make any other cell. You can make Leclanche cell, you can make voltaic cell, and any other cells. Just what you have to do is that you have to change the electrode and the electrolyte, and you have to what you can say use it. Now every time it is not possible to draw it in this way and what you can say explain the children. It's not possible. Even in the exam, suppose if I give you a question, do you think that I have to write in this way and I will be giving a question? Will it be easy? Or you have to answer me means will you write in this way and you have to answer me? Not possible. So we have got a representation for it. Alright, we have got a shortcut method to represent this particular cell. So hence now I am going to teach you the cell representation. How to represent this particular cell. Alright, listen it now and understand it. So when you are representing a particular cell, always the oxidation, listen carefully, always the oxidation reaction is written on the left hand side, and the reduction reaction is written on the right hand side. Oxidation means, got it? That is M/Mn plus. Because in oxidation what it happens? Let us say M is there. M means a metal, any metal. It loses N electrons to form what? Mn plus. This is an oxidation reaction. So that's what I have written it. M/Mn plus means what? This is a shortcut way of representing the oxidation reaction, which should always be written on the left hand side while representing a cell. Left hand side, listen carefully. Oxidation reaction, that is anode, the reaction which is taking place at the anode should always be written on the left hand side. Now reduction is what? Mn plus Ne minus will give you what? M. This is reduction reaction. Now it should be written on the right hand side. That means Mn plus to M. Here what you got? M to Mn plus. See, M to Mn plus by loss of electrons. And Mn plus to M, it is how much? By gain of electrons. So what will you write? Mn plus to M. This is a general representation I am showing you. And in between I will put a double slash. Double slash is what? The salt bridge. So this is your oxidation part, the anode, and this is your reduction part, the cathode. So this is the cell representation, and you have to always write in this manner only. Always oxidation written on the left hand side, reduction is written on the right hand side. You can't change it. You can't change it there. You can't change it, this particular thing. Got it? For example, the galvanic cell. What will I do? So what you have seen it, Zn minus 2e minus gives Zn2 plus, and Cu2 plus 2e minus will give you what? Cu. So this is your oxidation half cell reaction, I said you, oxidation half reaction, and this is I said you reduction half reaction. So how will I represent this particular one? I represent it this way, Zn/Zn2 plus double slash is a salt bridge. Double slash means a salt bridge. Gives means Cu2 plus gives Cu. Always oxidation left, reduction right. If you are changing means meaning is going to change. How will you know? For that purpose, internationally, according to IUPAC, we have adapted this particular thing, that whenever we write something on the left hand side, that means I am writing the oxidation reaction, and whenever I am writing here, that means I am writing the reduction reaction. And here also you can write the concentration here. Suppose if it is 1 molar, you can write below 1 molar, or it is 0.5 molar, we can write 0.5 molar. We can write here solid, or you can write any liquid you have taken or gas you have taken, anything, everything you can write it there. So this is known as cell representation or the cell notation, we can say that. Cell representation or cell notation. Got it? The rules what I said? Oxidation left, reduction right, in between double slash is a salt bridge. Alright, in this way we represent a particular cell, this shortcut way of representation. Now, next, after that we will understand electrode potential. Electrode potential. So, when an electrode is put into an electrolyte, three things can happen. Three things. What is that? Either it can lose electrons, that is, it can undergo oxidation, like zinc, you can see it here. It loses electrons. Alright, and it undergoes oxidation. Listen carefully. Now, the second thing it can happen is that it can gain electrons and it can undergo reduction. like in case of copper you have said it. Alright, copper is gaining electrons and it is, what you can say, it is forming copper atom, we can say that. Alright, so or the third thing it can happen is that neither it can lose electrons nor it can gain electrons. So what is that type of electrode? We call it as null electrode. Null means inert electrode, we can say that. So there are certain electrode which does not participate in the electrolytic reactions, which does not participate. So they are considered to be as null electrode. Alright, and the potential of that electrode is considered to be as zero potential. Yes. So when I say null electrode means what I said, neither oxidation nor reduction. See, if a particular electrode neither undergoes oxidation nor reduction, then what will be the potential? Zero. What will be the work done? Potential is the what? What do you mean by potential? Potential in physics you have studied, it is the amount of work done in bringing a unit positive charge from infinity to a certain point. Are you doing any work if it is not going any, what you can say, oxidation or reduction? No, nothing. So hence there it is zero potential. We'll prove it also, don't worry, I am going to prove it also, that how the null electrode is of zero potential. Alright, so three things can happen when a electrode is dipped into an electrolytic solutions. Either it can lose electrons, that is oxidation, or it can gain electrons, that is reduction, or neither it can lose nor it can gain electrons, that is neither it can go oxidation nor it can undergo reduction, that is that particular electrode is said to be as null electrode. Okay, thank you very much. Next video.